All right, today we're going to talk about cosmology and the cosmos. The cosmos is just the universe. And when we're studying the universe, we want to know things like where did the cosmos come from? Where's it going? What are the principles by which it currently operates? One of the assumptions we always make when we're studying the cosmos is the cosmological principle, which is basically just that the universe behaves the same way everywhere. That we happen to be one part of the universe, but we assume that things aren't unique just in our corner of the universe or from our point of view. This is the same assumption Isaac Newton made famously when he was sitting under the apple tree, and he watched the apple fall to the ground, as the story goes. And he thought, what if the same force, gravity, that was causing this apple to fall is the same force acting on the moon, which keeps the moon in orbit? And this assumption turns out to be correct, and the only reason that the moon doesn't fall to the ground, you might be asking, why doesn't the moon fall if that apple falls? The only reason is because the moon is moving so fast in this direction that it falls at exactly the same rate as the spherical Earth curves down away from it. So it goes so fast it's falling towards the Earth, but the Earth is curved, and so it's moving around the curved Earth in a circle. So let's look at some of the theories now, the competing perspectives on how the universe came to be. So one of the ideas, or the main idea you may have heard of, is the Big Bang Theory, which is that there was a Big Bang. Your text says it started as a fireball. I think that's a little bit misleading, because it wasn't really a ball as we would know it, and it wasn't really fire because it was much hotter than any fire that we would know, and it also didn't really emit any light. For the first 300,000 years, as you may recall, the universe was dark. So the Big Bang Theory basically says that there was a singularity, I like that word instead of fireball, about 13 billion years ago that exploded for some reason. We don't know why. We don't know what a singularity is, because compressing all the matter and energy and space and time in the universe into that small of a space kind of breaks all of our laws of physics, and we don't really know how to describe it. It goes beyond what we can observe and therefore make predictions about. So the Big Bang Theory says that that happened, and then everything now is expanding outwards at a rapid rate, and seems to be expanding continuously. Some people are uncomfortable with the Big Bang Theory because it sort of implies that there was this beginning and perhaps a beginner or a creator, because things haven't been the way they are forever. But there have been theories that have said, well, maybe things have been this way forever, and there's no need to appeal to a creator to explain the universe. One of those theories is the oscillating theory, which basically says that, well, sure, the universe is expanding now, but at some point the gravity of all these objects in the universe is going to be so much that it will then things will then begin contracting down into a big crunch, which is the opposite of a Big Bang. Basically, everything will go back to a singularity, and then they can once again expand in a Big Bang. So that's the oscillating theory. The inflation theory is basically just the current model for the Big Bang Theory that's the most popular. So the inflationary theory is basically just a form of the Big Bang Theory, and it's the most popular one currently that most scientists agree with. The inflation theory basically just tweaks the Big Bang Theory a little, saying that in the first second after the Big Bang, it went even faster than it expanded, I should say, even faster than it's expanding now, and then it slowed down again. And that explains a lot of things that the Big Bang Theory didn't quite explain, like the homogeneity of the universe and some other things that I don't entirely understand myself. But cosmologists seem to understand. Then there's the steady state theory, which is another one of these theories that things kind of go on forever. And basically the steady state theory says that things are expanding, moving outwards, and they start out small, and we actually know that things do get bigger as they expand away from the universe. They kind of thin out, and so these objects, as they're moving out, they get bigger and bigger, and they thin out until they kind of thin out into nothingness. And new matter is created at the beginning, and just continually new matter is created, and everything just continues moving outwards forever and ever and ever. And this way you don't need a Big Bang You don't need this special inflationary period in the first second. You don't need to oscillate or anything. And people that hold to the steady state theory actually hold to what's called the perfect cosmological principle. If you remember our first slide, the cosmological principle that everything is the same in the universe. And this kind of implies that everything has been and always will be the same in the universe. It's always doing this thing where it starts, matter starts from this beginning and it just keeps moving out and expanding out until it kind of spreads out into nothingness. That might not be the most accurate way to say it. One question you're going to have here, it's going to say most scientific evidence available today supports the, and you're going to say to yourself, well, the inflationary theory, because I know that's the modification of the Big Bang theory. That is the current theory that is the most accurate, because you've read your text carefully and you know that. But you'll find that I've asked them to change it. I don't know if they will or have yet, but that actually the correct answer here is the Big Bang theory, because we still call the inflationary theory the Big Bang theory. We just call it the inflationary Big Bang theory. So you might click this button, but you might also explain that the inflationary theory is the current theory. Actually, anytime that you're not sure if you have the right answer, but you want to explain yourself, you can click on the help button, which isn't here on my key, and that'll give you help for understanding, or that'll help me know if you really understand what's going on. All right.